Thank you, all of you, for being here today. My name is Bradley Flam. I'm the director of the Office of Sustainability here at Westchester University. We and the Office of Research and Sponsored Programs are sponsoring this Sustainability Research and Practice seminar this semester, and we're really glad that you're here today. Just a couple of quick comments before I turn the floor over to Mr. Pat Brunner from Facilities, who will introduce our speakers today. This presentation is one of 12 that we have scheduled for this semester. Last semester we called it the Sustainability Research Seminar. We're very happy that this semester it is renamed the Sustainability Research and Practice Seminar. And this presentation in particular is really helping us see how sustainability principles are not just for academics and researchers, but affect the work that people in many, many disciplines do. So today we have a presentation from some collaborators with our facilities department. I'll let Pat introduce them by name. And at the end of the semester, we'll have another presentation by some collaborators of facilities who will tell us about the new landscape master plan for the university. But there are many other presentations. We have a flyer up at the front. If you don't have a copy, please take one. Whether you take one or not, make sure to sign our sign-in sheet, which is going around. And if you don't receive our weekly email bulletins, please indicate that you'd like to get it. Because there are lots of things going on campus related to sustainability. I don't want to take too much time mentioning all of them, but if you get the bulletin, you'll get details on other fascinating opportunities we have. So without further ado, I'll pass the floor over to Pat.
Good morning, good afternoon. My name is Patrick Brunner, and I'm Director of Facilities Design and Construction. I'm going to introduce my colleague, Catherine Joseph, who will go from there. I just wanted to say that if folks have any questions about facilities on campus, do feel free to send me an email, call me. We can chat about things. And don't feel like you have to be in the dark as to why this is broken or what are you guys doing over here. I'll share with you what I can. I'm not always at liberty to share with you things that are potentially being cooked by those who are more senior than me at the university. We'll see what we can do to help you. So without further ado, Kathy.
Hi everyone, I'm Catherine Joseph. I'm the Assistant Executive Director at Facilities Design and Construction, and I have been given the duty and the honor to be the project manager for the Science and Engineering Center and the Commons. Some of you may have heard it called the Commons. It has a longer name now, as we know that program that is going into it. Today we brought with us Jennifer Grafton, who's with Stantec Architecture. They're our lead architect. This project's gone through, some of you may know, a few different reiterations. So we've actually been working on this project with Stantec since 2014, which is a pretty long time for the beginning of a project. Also, as part of their team, we've been working with Scott Kelly, who is with Revisions. They're both Philadelphia local firms. We've been very excited to work with them and want to sort of explain to you the involvement we've had and the engagement we've had from the beginning of a project and how strategically Pat and myself and the others at Facilities want to have that part grow, that we have an involvement with more of the community and with other folks from the day one on projects, because we think sustainability should be a part of all of our decisions, especially on these major initiatives from the campus, from the very beginning, from the very concept. So we're excited to show you what we've been working on and excited to work with you more in the future. I'll pass it off to Jen and Scott.
Okay. My voice is not so great today. Sorry about that. We're doing the best we can. Today we're on the agenda, by the way, that's everybody right in front. Today we're going to do a little bit of introductions, which we just did. I'm going to start and try to bring out some big picture issues on sustainability. And this is done to be a little more fun for you to understand, and also to understand what we do at the very beginning of a project to help it be sustainable. Jennifer then's going to get into some specifics on the comments, and then we're going to try to do a couple of closing thoughts. I don't like boring presentations. So if you have questions as we go through this, interact with us. Ask questions, let's talk through stuff. Hopefully, at the end, we get to a point of some lively discussion. Make sense?
Yes.
Okay, I'm going to tell you some stories. This first story, I'm borrowing from David Brower. Does anybody know who David Brower was? Older people know who David Brower was. Any young people? No, okay. So David Brower was the founder of the Sierra Club. And he tells the story of the evolution of the Earth, but he does it with a biblical reference. He's going to tell the story with 7 days of creation. Actually, it's just 6, right? So on the 7th day, what do we do? Rest. Rest. Good. Everybody knows the story already. All right, so I'm stealing his story, and I'm going to lay out what happens basically with our plan over this whole time frame. So I'm going to jump right into it. Every slide that you're about to see represents about 750 million years of evolution of Earth. The entire evolution of the Earth, about 4.6 billion years. Our evolution of the galaxy is about how long? Do you know? 13 some billion. Long time. So let's get into the first day. So on our first day, we really just have our geology is forming. We're still a very hot mess. It takes 30 million years for the surface of that ball of lava basically to cool enough to even have a crust. Very, very long time. Another 750 million years go by. On day 2, which if you think about geological time, is very, very early, we have our first signs of life on our planet. Right? Mistakenly often referred to as blue-green algae or something, but basically it's a cyanobacteria. It is the majority of life that's on our planet. It's in very few places. Day 3 comes along. After all of this activity, we begin to form something called our biosphere. Can anybody give me a definition of what our biosphere is? You didn't know you were going to get quiz questions. But I can't let you fall asleep. What's our biosphere? Anybody? Oh my God, you guys are killing me already. The biosphere is a layer.
Intersection of lithosphere, hydrosphere, and
Yes, keep going. It's everything where there's life. All the layers around the Earth. Nothing beneath the biosphere is alive, nothing above. It just contains all life. Down at the lowest levels of the sea, all the way to the highest levels of air. Okay, that's our biosphere. So it's beginning to evolve. We have photosynthesis and some other things that are coming out of the ocean, essentially, that are producing oxygen, and that oxygen is then forming our ozone layer. We're beginning to form that. About half the history of Earth has already gone. We have our first sign of plants on solid land. Very, very long time has already gone by. Day 5 in our geological cycle here, free oxygen molecules begin to make that ozone layer. What does the ozone layer do for us?
Shields.
Shields. Who said that? Great. Right. Shields out all kinds of stuff that lets us live on. Without that ozone layer, we're not here. Right? So a little time goes by. Let me just make one very quick point. Our biosphere, that layer of all life, this is out of scale very much. If I was holding a ball about this big, the biosphere would be about as thin as tissue paper around the Earth's surface. Right? That's it. Very, very, very thin. Okay, day 6. This is where all the fun stuff happens. So at 1 a.m., we have amphibians work their way from the ocean into on the land. 4 p.m., my kid's favorite thing, dinosaurs. Right? They show up. And the interesting thing about dinosaurs is they're here for 6 hours out of 6 days. Dinosaurs are here an incredibly long time if you think about this whole cycle. And then what happened to the dinosaurs? All this is on the quiz at the end. Why did what is the current theory of why the dinosaur went extinct?
Meteor strike.
Yep. What happens? Huge meteor slams into the Earth, kicks up enough of the crust and debris into our biosphere, which causes catastrophic failure because the biosphere was interrupted. Sunlight gets blocked out. What happens when sunlight gets blocked out? So it's easy for you. What's the first thing to die? Plants. What's the next thing to die? Yes. Anything over about 50 pounds basically goes extinct. 75% of life on Earth, gone. Biosphere was disrupted. There's good news in that. Because once they go, once the dinosaurs go, what happens? We show up. Where are we? We're down here. Now, we started about 6 seconds ago, which is a very, very short time compared to everything else. So our story is quite new, to say the least. And about 1/40th of a second from current time, we begin to do something very, very different on our planet. Right? We begin to take stuff out of the Earth's core, crust, that took the Earth 4.6 billion years to sequester, to make our planet habitable. 1/40th of a second versus those 7 days, 6 days. We took all that material out of the Earth, doesn't matter what it is, could be oil, could be gas, could be lead, could be copper. We took it out of the layer that kept us safe, and we threw it up in our biosphere. This is what we currently do. It's okay. The Earth will be fine without us or with us, doesn't matter. But we haven't really thought through those ramifications. But people like me that are environmentalists, I am an environmentalist, see, ponytail, clouds, got it all. I concentrate on CO2 emissions. They're incredibly important. But I am very well aware that if we do not address all of the other issues of toxicity in our built environment, in our food, in our transportation, and the way that we live, we can fix global climate change. We then have this other thing coming at us that's even bigger. So we need to broaden our view of how we affect the built environment and our environment, and change the pattern now. Because what we do in one building lasts for 100 to 1,000 years, depending on a bunch of different variables. So that's a little bit of the big picture.
Scott, I just wanted to say to everyone, this is how we began our first, so this is facilities meeting with our consultant for the first time regarding it's helping us think of these buildings we're making as the mark we're placing on the Earth. So this is, I want you all to realize that this is how we started our meetings, and this is when we say day one, Scott didn't just do this for you here, this is how we started our project and when we were conceptually thinking about building on campus. So we're trying to pull back and look at what we're doing, so. And then we did this.
Say we take a break. I had to show a cute picture because the rest of the message before this isn't great. I'm going to show you. I showed you the cats. The point here is we are trying to turn the light bulbs on in people's brains so they're thinking differently about the process. And as Kathy was saying, we got together as a team. We did these kind of exercises to frame out the big picture first. So we're all playing on the same team, trying to solve the same issues in this building. So to keep things green and sustainable from the beginning, you need to turn everybody's focus in the same direction and then keep them focused on the goal. We'll talk about how to keep them focused on the goal in a little bit. I'll very briefly cover early engagement, and this is some of what we did. We're talking about it now. I am an architect, so I'm on the design side, but really what I am is a high-performance building design consultant that helps other teams reach these kind of goals. Typically, the designers kind of come in through the process a little bit, but not necessarily at the very beginning. We have some influence on what happens, and if we influence stuff early, the cost impact is very low. If we make changes at the very end of the project, it gets very expensive. Right? So our sphere of influence, very high. We can make really big impacts for the environment and on cost very early, much harder to do at the end of the project. This is why we take this early engagement process. I'm going to skip some of this. On this project, I'm going to go back for a second. We know the highest value changes were at the very, very beginning. I'm not going to steal your thunder. Jennifer will talk a little bit about those high value changes.
So where are we in the process?
We are right about here for this. We're almost on construction documents. So the end of the documents that then get passed to the contractor to build what the team has set out to do. We use a process of feedback loops. From the very beginning, we're doing a lot of research, we're doing some development, stacking diagrams, all these things to frame out the building, doing a lot of analysis. We're finding from the feedback loop to the point that we get to the very, very end. That's kind of the summary. To keep us online during the process, we start off on a good foot, but then we fundamentally use leadership in energy environmental design, a benchmarking system to benchmark how we're doing through this process. And use that scorecard as a framework, and only a framework, to get us to our end goal. It will give us a rating at the end, but we go far beyond just the framework. The framework is just the start. And we'll talk just briefly a little bit about some of those other strategies. I don't want to take up too much time, so Jennifer, can I pass the ball to you, and you could talk a little bit about other variables? Okay. The one on the right is advanced.
So before we get into the details of the Commons building, I want to just take a quick step back. And as Kathy had mentioned earlier, we've been working on this project for over 4 years, collectively as a team. And this project initially started out as a 60,000 square foot dining facility to replace Lawrence Hall. And at one point along the process, the university president at the time had decided that it seems sort of foolish and not forward-thinking to build small buildings, especially on a campus of this size with limited resources. So we need to be thinking more into the future, building bigger buildings. You know, Scott talked about how we take things out of the earth. You know, the more we do that, the less sustainable it is. So the bigger building, the less construction you're doing is inherently sustainable. So we've taken the 60,000 square foot dining facility and we supersized it into a 180,000 square foot mixed use building, which is kind of unique to a lot of campuses across the country. This is probably one of the first mixed use buildings in the region, but we are checking a lot of boxes with this project. We are not only replacing the dining facility and making it more sustainable in its operations, but we're also providing classroom space, we're providing office space, we're providing common area, gathering space that you don't currently have on campus. So we're effectively taking one project and building a lot of different things that will be flexible over the course of time. Hopefully reducing the amount of further construction that you guys have to do as you're trying to plan for the future. So Sciences Engineering Center and Commons, big building, big title. So some of the strategies that we take are, I think, are pretty obvious. We aren't doing anything out of the ordinary at this point in time. You know, sustainability was sort of unique a number of years ago, but now I think we all design with sustainability in mind, whether we're doing a benchmark system like we've done. So energy efficiency, we try to make sure that we're orienting the building properly in terms of taking advantage of natural light. So, you know, we're also evaluating the types of glass that we're putting into buildings. So, for instance, at the Commons, we worked with our mechanical engineer to study the amount of insulation and the types of insulation we're putting in the wall, because we don't want to over-insulate. At some point, you're spending money and not getting a return on it. We're also making sure that we're doing things like putting less visually or less transparent glass on the south side of the building where you're getting the most intense sun, and making it more transparent on the north side of the building. We're also running energy models as we design the building to make sure that, you know, we are designing efficient systems. And we also are looking, we have a lot of LED lighting on this project, which, you know, that of course is a huge energy savings on the lighting side. We have daylighting controls. As you may have seen in that first image, we have this enormous glass box, which is part of the dining facility. And so we have studied ways of using appropriate glass. We're providing some fritting, which is like little white dots on the glass, to help cut down on the amount of heat gain coming into the building. And we have also integrated a motorized shade component that actually is directly connected to a photo sensor. So whenever it gets really bright outside, those shades will come down and help reduce some of the heat gain inside the building. So these are some of the strategies that we're doing to make the building as energy efficient as possible. Let me know if I missed anything.
All right, I'll chime in. I don't know which one.
Water efficiency. This one is sort of difficult in certain aspects on this project. Because this is a dining facility, we use a lot of water just to keep keep everything, clean and sanitary. So, we have some things that we can't do in terms of water conservation, but we also have a lot of science labs, which includes a lot of sinks, a lot of research labs, a lot of things, bathrooms, of course. So we're trying to make sure that all of those fixtures that we're using in those spaces are as low flow as possible. And that's also giving us a tremendous amount of water savings on this project. And Scott, do you recall where we are on
I think
the?
it was 35% is where we are. I also want to add this. People tend to think of water and energy separately, but they're really not. Because with that water comes the ability where the need to often heat it. So if you're heating your water, let's say you live in a dorm here. That dorm, the energy usage in that dorm is probably 25% in hot water alone. So if you can take out 40 or 35% of your hot water load out of that 25%, that is huge amounts of energy that you're not using. So the two are very, very, very linked.
Yes.
Gray water systems?
We do not have a gray water system. However, we are harvesting the condensate from the air handlers, which will really be producing a lot of condensate over the kitchen area, and we're going to capture that, and we're going to use that to irrigate the planting beds on the green.
So technically that is a gray water system. It still falls.
Well, yeah, I guess you're right, it
Right.
is, but we're not using the toilet rooms.
Correct.
So we're just using the condensate, but it is a
Someone mentioned in a meeting just before this that they were thinking about putting the food waste into the wastewater stream.
Food waste can be separately composted.
Composted or digested?
We're using dehydrators on this project, and then I apologize, it's sort of a newer technology for my experience, so this is something that that's becoming more of a replacement for the digester, so I can't speak specific to the dehydrators, but I'd be happy to get some more information for you guys.
Basically, the dehydrator lets you put it back in the food cycle and put it back on farmland. So you're closing that loop the best that you possibly can. The issue that we have with a true composter would be the volume would become too great for the building. So we have to kind of get the volume down. Inside this facility.
One thing I didn't mention, which I guess we probably take for granted at this point because it's just been a part of the project from the beginning, is the campus has a geothermal loop system. So we are designing the building to run on the geothermal system, which obviously there's a great sustainability story associated with that as well. Materials. Again, this is something that's become pretty commonplace. I think everybody's familiar with what kind of materials are better and less good for the environment. So as we design the building, we're thinking about, we're trying to use greasing brick and stone, natural materials on the exterior of the building that have a long service life, require low maintenance, which is also a component of sustainability. Inside the building, we're using low to no VOC materials in terms of the carpeting and the floor finishes and even the adhesives that we're using.
The other thing we're going to do is we're setting up green cleaning procedures. So after 5 years of work, all the hard work we do in selecting materials doesn't get essentially blown in the first week. And so it goes in and cleans the building with toxic stuff. So there's policies in place to make sure that the ongoing maintenance on this building helps us keep volatile organic compounds out of our body.
And one of the strategies we've had is we've been working closely with facilities in selecting materials, because not only do we want to pick materials that are good for the environment, we also want to make sure they're durable, because ripping out drywall that's been damaged and needs to be replaced and throwing it in the landfill, not sustainable. So there's that maintenance, longevity component of sustainability that we really take seriously. There's just a lot of different things you might find in a building, and as you can see, we have all of these in common. And so, we're just trying to make sure that everything that we're picking.
I want to add one thing to this slide. We as your design team can do a lot of good, but the occupants of the building are half the game here. So what you bring into the building makes a very big difference to the indoor air quality. So as you begin to get more knowledgeable about what you wear, what you buy, and bring into the building, that's going to influence it too. And that's one of the messages that I think we need to talk about towards the end is your role in this process.
This site, this to me is probably the biggest story and the biggest transformation for this site and this project in particular. As you can see, the before shot on the left and the after rendering on the right. We are planning to take a site that is currently asphalt. It has a decommissioned boiler plant on it, so we have a brownfield site that we're going to be removing the boiler plant. We're going to be removing all of the any contaminants that are in that facility or around the facility, removing them from the site, and building a beautiful, in my opinion, building. And it's a low-lying building, so scale-wise, it's very, it feels, it's not a big looming building. It's still very intimate with the site, but it's also created a lot of opportunities for us to create pockets of green throughout the space. And this, we have an aerial landscape. You do side one. Yes. So this is probably the most telling. We have a substantial amount of, what do we talk about?
There's a laser on that, but it doesn't work on LCD screen. So you gotta use your finger.
So, as you can see, we have a substantial amount of green roof on this building, and we have a substantial amount of green on the site. We have been working in conjunction with the landscape architecture team that has done the campus-wide master plan, and we're trying to integrate a lot of their recommendations into this building. So this will be the first iteration of that campus master plan. But one big change that you may see is University Avenue is being called University Walk. So we're taking a very car-centric place on campus. For better, of course, I'm sure there's some opinions on that, but we're turning it into a very pedestrian-friendly area. And this whole zone is being developed as pedestrian-centric. This area here, this big white box, is actually a parking facility. So we're taking all of that, condensing it to one small area. And
condensing, sorry. Does that mean like parking spot wise?
No, not condensing it. You take all of this and build it for space for
oh, it's garage.
So, yes.
Yeehaw.
Yes,
Okay.
garage. No reduction. Meeting all the zoning requirements for parking. So, big thumbs up there. And again, we're just redeveloping the site and we're really recreating what's happening. With a lot of green, we have a lot of sorry, I'm at a loss for words right now. A lot of new trees that we're putting onto the site. I believe we're adding over 150 new trees to this section of campus. So it is a pretty substantial impact. We're using a lot of natural materials on the site and on the facade of the building with a lot of stone and pavers and trying to create a lot of activity here. You're not going to hang out in the parking lot. So what we're trying to do is create areas where we have seating around the building. And we're really looking to activate this section of site and really sort of tie all the areas of campus together. When Kathy describes this project a lot of times, she talks about the intersection of all the different components of campus. There's the residential, we have dining, we have the academic, and they all sort of come together at this area. So we're trying to take advantage of that and really create a wonderful space. All the green that you see is how we are meeting all of the land development requirements for the borough. We're capturing a lot of rainwater. We have some retention basins. We have the green roof, which most of it is an unoccupiable green roof, but we do have a section here with that can be occupied. It's got paving, it's got plant beds for a couple of the programs in the building. And that's when we talked about the use of the harvested condensate from the mechanical units. Another great sustainability story is you've got public transit very close. We have bike share on site, we have bike share adjacent to the site, and also lots of bike racks, we have skateboard racks. We have a lot of really cool things to get people out and about. We have, what else? We have the car share parking facility. We have electric car charging stations in the parking facility. There's preferential parking for limited vehicles. So we're really trying to, I think the site is probably the biggest transformation and where we're really getting our biggest bang for the buck.
Will folks have a chance to like participate in any of the tree planting, or is that like something for just the construction guys and we won't? I mean,
At this point in time, everything that we have in the project is a part of the construction construction project.
Okay,
But they're, Kathy can speak to.
just wondered.
Yeah, I mean, Pat, we haven't discussed, as part of a bid package and part of a construction project, the
Right.
trees are part of the
That makes sense.
project, but we haven't, I think there will be lots of ceremonial, I mean, there's even discussions, people, you're asking, am I thinking about planting trees? I've been asked, hey, can I be part of taking down the boiler as part of the demolition? So, we're trying to, as we want the, whole campus community to be excited about this project, I think there will be opportunities like that, and, we're trying to see how we can, okay, yeah, let's see if we can get people there to demo, and if we can get folks in there to plant, I think there will be ceremonial, but I also think there will be, more of a, and as we learn more about like these beds on top of the roof, they right now were requested as part of the nutrition and health programs. But I think there's going to be an ongoing part of this project too, that it's not just when the project is first built, but how we keep up with all of this for the generations. So
Good.
And I tend to see with projects like this that are very transformative, that excitement starts to lead out from the project site proper. So, there may not be specific opportunities within this construction project, but certainly you've got a lot of beautiful lawn space surrounding here that, there may be opportunities that, groups such as the sustainability group may decide to adopt and,
Right.
tree tenders group. So I think this is a great catalyst.
Okay, we did want to have a couple closing thoughts. Anybody know why I put this slide up?
Beautiful?
Yes, that's exactly why. You picked it. It has nothing to do with the presentation at all. I just thought it was really cool. It's like, this guy's riding a bicycle. I love it. But it does also bring me to a a couple of points. Maybe I put the bullet points on that last one. Did I? Yeah. A couple of points here. So our impact on the environment, if you think about it in its totality, we can pretty much sum it up into 1/3 of that impact is what you eat. It's beyond this building. But it's part of our daily choices and what we do. The other part of it is where you live, when you go to school, and how you get there. Those things are also incredibly important. So 1/3 of your impact is your transportation. The closer you are to live to your education, or the less you drive, the less impact you have on the environment. It's not just the building. You need to go beyond just the built environment and go into the way that we all eat, commute, and live. We all are the guides here when it comes to changing our culture. None of us can learn a bit about what we do right or wrong or what we could do better and not share it. We have to advocate, we have to communicate with each other, and we have to have discussion about what's best and what's less good. So we all have to be the guides. It can't just be the design team. It can't just be the teachers. It has to be the students and the community. And that's how we get significant change. And a challenge for you, I don't remember exactly how it went, but hopefully you learned a little something today about green and sustainable thinking and about this building or some technology that you think is cool, or some way to engage in the community by actually helping construct parts of the building, planting trees. Take that home and share it. Share it with the people you live with. Share it with the people you talk to. And be a good advocate for green sustainable thinking. That's what's going to help us make substantial change. So it's our job to make a green sustainable building, but it's your job to play a role in it. So I'll stop there. You guys want to add anything?
It's hard to follow that stuff.
And I think our main ad is really to reach out to Pat and I and facilities. We are looking for, I know times on a university of this size, there can be chatter in different groups, and we ask you to bring that chatter to us. We are trying to solve problems, and we are looking for what are folks' concerns, and we think, if it's just getting chattered over here and we're not hearing about it, we can't help be part of that process. So we do want to hear from folks. We do want to know what your concerns are. We do want to hear when you're happy about things, about the trees. So, but bring it to us, and we're open to that discussion.
We get really good ideas from you guys. I mean, we're not the ones generating all, we're working on your ideas.
So are there any life cycle accounting on how much carbon greenhouse gases this building will either generate or drop out?
No formal, but I can give you some math. In its operations and use, you're down about 30%, 40%. These are my back of the napkin sketches, or my back of the napkin math.
This building's still going to be a net generator.
Oh, yeah.
And so is there any talk about renewable energies or ways to increase net climate productivity so that we're creating a space that is offsetting?
Not yet, but we did try to find this balance between, do we put photovoltaics on the roof or do we manage our water? Which strategy we're gonna hold up and do the most at this point. There is no reason that the conduit to run photovoltaics later on cannot be in this project. But we're not at the point, at least my understanding, we're not at the point yet where we are putting photovoltaics on the roof. But what I can tell you is the university helped me out with the stat. I believe purchases about 35 or 50%.
10%.
10%?
From the wind farms is 10%.
Okay, there you go. So there's the stat. So we're moving things in the right direction. Does that make sense? Okay, the other carbon footprint thing that we're doing, and this is something that not everybody fully understands. The carbon footprint of the building in its operation is part of the puzzle. The carbon footprint of the building in its construction is a huge part of the math.
Right, so you want to protect the trees and the envelope around the building, for example?
Yes, but more importantly, the biggest life cycle assessment, the biggest carbon footprint is in the concrete. So concrete, surprisingly, is worth about 6 to 7% of all global CO2 emissions. It is a shockingly high number. So what we're doing in this project is using a blended cement. And the blended cement basically replaces the Portland cement, which is a very high carbon footprint, with slag and fly ash. Therefore, using a waste product, keeping it out of the waste stream, and lowering the carbon footprint of this building significantly. I'm taking a guess, I didn't do the math on this, just back of the napkin stuff. The CO2 footprint, the carbon footprint of this building, probably 30–40% of it is in the concrete. Staggering. And we're going to cut it by 40%. That's really, really impactful.
Will you be able to get to the point where these calculations are not just back of the napkin, but are actually quantified?
It can be done. It's expensive. And so the challenge is, do you spend a lot of money on soft costs, meaning the costs for you to do the math, or do you spend the money on another trade, or I should say a lot of trees? And so we have had those discussions of where the best investment is. And right now, where I think Leland is the best investment is in the green strategies building, rather than proving out all the math. But it's part of the construction process. We'll have the submittal from the contractor on the percentage of blended cement. And you can theoretically approach it to say a certain percentage of its carbon footprint is in that blended cement.
But this is an interesting question because there have been conversations at this university about the life cycle costs of designing our physical infrastructure in this way versus a more traditional, perhaps lower initial construction cost strategy. And I think in the long run, it's important for us to be able to say that the Business and Public Management Center building, designed to higher environmental standards, the Science and Engineering Center and the Commons, the Mitchell Hall renovations. It'd be nice if we could be able to compare perhaps some extra upfront costs we might be accepting to a long-term life cycle cost in terms of financial impacts and in terms of carbon emissions.
Things like the immediate energy use in the building is so easy to do, to calculate, because we've already got the math. But the more deeper you get, the more accurate you get, there's some cost implications to that. I agree with your statements. We just have to figure out how deep to go in the way of measuring something.
Is there a way that some of our faculty and students and staff could help with those calculations so that we as a community feel we have better understanding of what impacts the decisions we're making now?
Yeah, I can't speak for Westchester because I'll get in trouble really quickly.
I think, really, Brad, this is a conversation with your new role here, and,
Yeah.
you know, this is a question that maybe hasn't been asked before. And I think this is a conversation we have to start having internally and finding out the ways to do that. I think our whole mission, besides my 7-day speech we had at the beginning, was this building is a learning opportunity for, that's what we want it. We want it to be part of the learning environment of the campus. We want every part of it. So we want to see, oh, can this be used as part of a class or an academic program, or is this something the administration is working on and we're learning from? But we see this project as a learning opportunity. So I think this conversation has to continue from this room and go to the folks who can make that happen. Because I think that's where the opportunity is with this building. As he's saying, we're the stewards of it, and we're the ones who carry it on. You know, so I think us taking ownership of that information and finding it and using it, I think would be great. So I think we have to work together to figure out how that could happen.
Good, let's keep that going.
Yeah.
Can we measure the waste that comes out of this building? Make sure it's being recycled, and its operations and use? Is that something the students can do?
That's what we're talking about with the dehydrators, like how can they be part of the academic program? You know, like
Can they weigh it? Sure.
I don't know
It's a
enough about
$50 scale.
dehydrators to say whether or not that's a good long-term solution to our food waste situation. I do know that food waste creates an incredible amount of greenhouse gas and carbon dioxide emissions if it's not handled correctly. And everything needs to go back in the soil. That's the most climate change, carbon offset, acceptable, most impactful thing to do. So I don't know what a dehydrator is, I don't know what it does, but, and can we make this a water recycling building? You know, Oberlin's, I know we're a state-funded institution, we don't have deep pockets, but, you know, could we put up a challenge to make this be a building that doesn't use any water at all, it recycles all the water? You know, Oberlin's got their building, they got the Quaker high school building in Philadelphia that's, what's the one in Philadelphia that doesn't, the Friends
ones that we
building
worked on
that
is
doesn't
Friends
have
Center.
any, you know, they use all the water in the building, and I think this is great.
And I think that's where that conversation, that it may not be this building, but what's the next building on our radar? Like, what's the project coming up? You saw where we were on the chart of design for this building. So what I like about all these conversations happening, like Brad's role or our position, Pat and I are still relatively new, Jim Lewis, our other associate director, the new administration that we have, I think this is where the conversation has to go. What's that next project? Because we want to be in on that conceptual part. So I think it's a valid point. I don't think we can do it for this one, but I think the step is we're doing it for the next building.
We would have limitations on this building anyway.
That's
Through preparation center, there
science.
would be aspects that are
Yeah.
difficult.
Let me jump in for a minute. Having worked on the Friends Center downtown, being responsible for harvesting the water, working on a bunch of other net zero water, net zero energy buildings, there's a lot of resistance in municipalities. So we had to fight for years with Philadelphia to let us take the water off the roof. And what I think is most important is to take the appropriate steps that don't stop the project from happening. So if we went to the municipality and said, we're going to do great water here, I think we'd end up in court for years. So the right thing is to take the condensate, which is obtainable, and use it to the best that we can for something in the building. It's about taking that little step, so next time the university goes back for an ask, they'll listen. But until we prove it to them, it's tough to make them jump all the way to the best solution. We all have to allocate, and includes you guys too.
Did you consider solar for any of the energy needs of this building?
We did have discussions, Pat, I don't know if you want to jump in on this one about photovoltaic for this building. I'm trying to, when you first brought up stuff, I was like, what were the reasonings? Because we had reasonings why
Yeah,
for
because
this particular building, why wasn't put in, and we were starting to pull back and looking at university-wide, where's our best option for photovoltaic? And a lot of us were talking, I think we still have some options on, future options on the garage. We had talked about that there's potential for photovoltaic open top of the garage, this we decided was going to all be green roof, and that's dealing with our, stormwater. So that was part of the determination. I do believe there is still, it's not in the project right now, it's not in the cost, budgeting, but it was pulling back and trying to find out the use of photovoltaic campus-wide, more than just this specific project.
That's what we would enough for you.
What'd you say?
We could lease it to Tesla. Because we don't use any solar on campus now, right?
A little bit, at
Very
the student rec center.
Yeah,
Right.
Student Center has it for
But
the.
what the campus probably needs is not to cover a roof that's 3 stories up with PV. You need to manage your water up there. You need to find a place to put PV on the ground where the kids can see it. Because that's part of what we're trying to do, is change perception and change everybody's understanding of it. So for this project, 3 stories up, probably not the best strategy. Find something else on campus that's at the ground where you can see it, and then design it in a way where you can track the wires from the backside where students can see how it actually is constructed and made.
So going back to the food waste, I'm unclear on the dehydration. Is the idea just to reduce the volume and then?
Volume and weight, there's 3 things, parts of it.
So the dehydrated food, it doesn't get spread directly on fields, it has to get composted in some way, or?
In full disclosure, this is not my area of expertise, but I'll do the best I can. So the reason you dehydrate is really this. You take out water, which is the majority of the weight, so then it's less expensive to move. You basically put it in a state where you do not have issues with insects, bugs. Right, because that's one of the big issues about composting inside your building is it can be attracting a lot of things we don't want. There's a third reason why I forgot it.
But it does get taken off-site and.
Yeah. And basically, ground up and then mixed back to the soil. Because you are trying to take that nutrient value and get back to the soil, but not necessarily the water.
And I would be glad to follow up. This is a continuing conversation. We did have a student, Professor Brad, I'm sorry, I'm forgetting their names, but we were approached
John Machado.
facilities about this particular issue, and I was also sort of like, hey, where did we, I didn't go back, just so you know, this drawing size is 700 sheets. There's 700 sheets about this building that we're going through now and detailing it. I said, wait a second, I have to dust off that part of my brain and go back and remember why we did that. And so I've been researching it to get back to folks, but I would love to include you in that conversation. We want it to be an educational piece of the building. Right now, there will be 2 of them. One is in the catering kitchen, one is in the main kitchen. There's 2 separate kitchens in this building. One is in the main kitchen with the dining servery area. Both of them, the interesting part about it is are part of our third-party food vendors, sort of, not their domain, but their area. So Pete, this is going to be an interesting collaboration between our third-party food vendor, who we're not quite sure who it is yet. As soon as we hear that will help us have these conversations, and the university and facilities. I think it's a really nice collaboration. We were also excited because of the Nutrition College of Health Sciences moving to this building, because we think there's a real, really nice component about that. They have their food lab also in this building, and it's going to be a really nice collaboration about all of these pieces. But that one's, because we all have this, not just us, we also have this third-party food vendor, which I think is a benefit to us, that we have them helping us with the process and where things are going and how, run under their domain. But I think it's a conversation that has to continue. We're not at a final point for that yet.
Unfortunately, it is 12:50, and we like to end this seminar on time because some people have classes to get to or other. So we are going to break at this point. I don't know if Scott and Jennifer can stay after if people have a few more questions, but please join me in thanking them for fascinating presentation. All right. Please take some cookies before.